Howdy, AP PreCal. It's Miss Kosh. Today I have a huge stack of multiple choice that Mr. Passwater wrote. I think it's available for examples, and hopefully I'm not doing the wrong thing by working some of them. He's made available Units 1 and Unit 2, and he might be changing things. I did notice that he has a newer version than what I'm working with, but I was not so motivated to print it again. So if we catch little problems, we'll just kind of roll with it. Please leave comments and down below if there's something that I do wrong or something that you catch or whatever. I don't intend to make his work available as a PDF, so don't ask me. Or you can ask me, I'll just tell you no. What else did I want to say? I won't do everything, but I'm going to do the ones that that stand out to me, and I have not thought about Unit 1 or Unit 2 in a very long time, and I have not looked over these problems. So I'm going to, as they come to me, I might work them, I might not feel like it, so we'll just see what happens. But this is the first video of me trying to make multiple choice questions as a review, or trying to work multiple choice questions written by Mr. Passwater as a way to help us review. Okay, so that being said, that was the intro. Here we go. Okay, so the graph models Mr. Passwater's distance from his home over time. Time in hours is the independent variable, okay, and distance is the dependent variable. Which of the following verbal descriptions would be appropriate? Okay, he leaves school and drives towards his house at a constant rate. Okay, then he stops to eat at a restaurant for a period of time. Okay, he's not moving at all through here, so that looks good. After eating dinner, he leaves and reaches and drives until he reaches his house, driving at a constant rate that is faster. Okay, I think that seems to be accurate. Notice a constant rate tells me that it's going to be linear. Faster means it's going to be steeper. So I think this first one is correct, but let's keep going. Mr. Passwater leaves school and drives towards his house, increasing his speed as he drives. No. There goes that. Mr. Passwater leaves his house and drives at a constant rate to a nearby restaurant. After stopping for a period of time to eat lunch, Mr. Passwater drives back to his home at a constant rate that is faster than his rate when he was driving to the restaurant. How is that different? My bet is that this is one of the problems that he updated in the new update. So maybe let's just assume that he changed that word to slower to give us a different scenario. He leaves his house and drives to the restaurant at a constant rate. No, leaving his house would mean that his distance from his house would start at 0. So no. I think the best answer is A, but I also think that this is probably one that got corrected. Okay, oh, I hate these problems. So you're going to watch me struggle. Okay, water pours into an empty container at a constant rate. The water pours until it is full. As the water begins to pour the container, the depth of the water increases at an increasing rate for a period of time. And then the depth of the water increases at a decreasing rate until the container is full. Which of the following would be appropriate? Okay. So what did we say? I really do. These are not my favorite. I love trig. Okay. As the water begins to pour at a constant rate, the depth of the water increases. Okay, so the depth is going to, well, let's see if we can think about what would that graph look like. Okay, the water's being poured in. It starts at 0, but it's increasing at an increasing rate. That means it's going to be increasing and concave up. And then the depth of the water increases at a decreasing rate. So it's still increasing, but now it's concave down. Okay, so that would be kind of what the height of it would look like. So what that tells me is it's going to grow. Let's think about this for a second. If we did this one, the height is increasing at an increasing rate, but then it decreases again. No. I hate these, you guys. What would I pick if I had to take the test right here, right now? I think that the height, if it's increasing, it's going to be pretty constant until here. Then, so this would have a constant because it seems pretty consistent there. It's like there's the shape of the glass is not getting wider or getting narrower for a little while, and so it doesn't say anything about being constant. So here it's you have to pour in a lot of water. And then it would be increasing. I think the problem with this one is that there's not much room for it to then decrease. So I'm guessing that the answer is this, and you're gonna just watch me pull up my, not watch me, but I'm gonna go over to my computer and pull up his answer key, and see if this is me checking. Oh, I was wrong. I hate these. They said this was the answer choice because it narrows, so that means it's going to get, as it narrows it, that the rate, the height will increase, and then it does widen again. So I was thinking the opposite here. I hate those. Okay, if anyone else hates them, luckily, hopefully there won't be a ton of them. Comment below if you hated that too. Let's see, let's try another one of the similar idea. For his birthday, he decides to go skydiving. Very fun. No thank you, personally, but as Mr. Passwater begins falling to the ground, the distance he falls increases at an increasing rate. Okay, so increases at an increasing rate, that means it's, the graph is increasing and it's concave up. So it's increasing and it's concave up. That's the only one, this is the only one that meets those requirements. Once the parachute opens, the distance he falls increases at a decreasing rate. So it's still increasing, but now it's at a concave down until he safely lands. Which of the following, the time is independent and his distance from the ground is a dependent variable. Well, you know what? Distance to the ground. Well, I wonder if this is another one we changed. He begins falling to the ground below. The distance he falls increases at an increasing rate. Well, he can't start at the ground if he's falling. Oh, they changed it? Well, okay, this is the answer that they give on the answer key. They switched it around a little bit. But distance to the ground, you don't start at the ground. So maybe did he change this? No, this is what they changed. Okay, I'm not totally crazy. What they changed on here is they said total, they called this total distance fallen. Now I agree. Okay, so this one matches the words, and when you change the directions on when you change that on the side, everything is great. Okay, that one wasn't so bad. Wasn't this fun? We love this. This is great. We love PreCal. Okay, let's see. Here we go. On the figure, this one, it goes from 0 to 9. Super. How many points of inflection? Okay, so I see that it's concave down, and then I see concave up to somewhere here, and well, I think this might be the inflection point. It seems to be, so concave down right here, concave up to this point where it bends on the axis, and then it's concave down, and at some point in here somewhere it's going to turn. So what do we have? We had one here, we had another here, that's 2. We had a third one here. I would argue that there's 3 of them. Okay, what is following, so from 7 to 9, what's happening? So from 7 to 9, it is positive. Nope, it's not positive. It's negative, and the graph is increasing. So that's C. Okay, which of the following from 1 to 3, what was happening? From 1 to 3, what were we doing? We're positive and decreasing. Okay, that's not the question. From 1 to 3, it is decreasing. They're not increasing, but it's decreasing and it's concave up. So concave up is at an increasing rate. So it's decreasing. Oh, we struggled with this. The average rate of change is increasing because it's concave up right here. The decreasing is decreasing. That wording is kind of funny. Let me check his answer key. Hang on, sorry. Oh, okay, he's changed a few things. On this one, which of the following statements of the graph is correct? It's decreasing at an increasing rate. Okay, I was right. It's decreasing at an increasing rate. So it's getting less negative as, so the average rate of change is very steep and then it gets less steep. Okay, so if you go from a big negative number to a negative number that is, so a big negative, think of it this way, if here's 0 and you have a negative number over here, and then at some point you have a negative number over here, that number has increased. So like if the federal government owes trillions and trillions and trillions of dollars, and then after a little while they only owe trillions of dollars, we're still screwed, but not as badly. Okay, not funny. All right. Which of the following from 0 to 1, it's increasing, it's decreasing and concave down. Okay, decreasing and concave down is right here. And then the next one from 5 to 7, it's 5 to 7 was here to 7. They're negative, it's concave up. So the rate of change is positive and increasing. The rate of change will be negative because the graph is, no. Oh, you guys, okay, hang on. The rate of change is definitely increasing because it's concave up, so we don't want those two. The rate of change between these is negative. It's negative and increasing. Let me make sure he agrees with me. Yeah, so yes, I was right. Negative and increasing. All right, we're gonna call that good for our first video. We didn't make it very far, but I'm gonna keep going and we'll see what we can come up with. I'm gonna try and, I'm not gonna do everything, so I may jump around a little bit and see what I can skip. All right, good luck. Let me know what feedback you have, and we'll go from there.